Welcome. So this is the level 2 trigonometry achievement standard, and this is the first new skill that we're learning, and it's the skill of finding the area of any triangle, even if we don't know what its height is, and even if it's not right angled. So what we're going to do is we're going to develop a formula for that, and that's one of the skills. Using the formula that we're going to develop as part of solving a problem is one of the skills that that you can use to achieve this standard. So example, you can see the triangle on your screen. We're going to develop a formula to find its area just using the information that's been given. So 2 of the sides and 1 angle. So the first thing is, what I'd like you to do is I'd like you to pause this video and think about how you would work out the area just based on what you already know. So you already know right angle trigonometry, so katoa, but we don't have any right angles here. And you already know half times base times the height. So pause the video and think about how you might solve this problem. So if we draw in a vertical line like I have here, which is the height, or we say the perpendicular height of the triangle, if we could calculate its value, right, then we could just use the normal formula, which is half times the base times the height. Okay, so can we find a way of calculating that height using trigonometry, so using so katoa? Again, pause the video and see if you can. Well, if we draw off to the side that part of the triangle, so this part here, and which 2 sides are involved in calculating the height? Well, we know the angle. Is the hypotenuse involved? That's the first question you should ask, and yes it is, and so is the opposite, because the opposite is what we're trying to work out. So we have O and H, so in so katoa that gives us what? It gives us sine, SOH. So we can write an expression for the opposite side, can't we? How would we calculate it? Well, we're trying to find which one. The height is the opposite side. So then we want to multiply it, aren't we? We want to multiply the hypotenuse times sine of 36.9 to get our height. So height equals hypotenuse, 5 centimeters, times S, which stands for sine of 36.9 degrees. What can we do with that? Well, remember, our goal that we're trying to achieve is what? Well, our goal is to come up with a formula that takes us straight to the area in one go without having to break it into 2 steps. So we want a shortcut formula. So why don't we substitute the height, 5 times sine 36.9, into this original formula of half times the base times the height. What would that look like? Well, in this question, the base, that's this whole distance all the way along here, is 6 centimeters, isn't it? Well, here, the half times the base means half times 6, because the base is 6, times the height, which we can calculate by going 5 times sine of 36.9 degrees. So let's write that down. Okay, and let's work it into a calculator. Now, on a graphics calculator, if we're going to use degrees like we are here as our angle, we need to make sure that it's in degrees mode. So at the moment it's in radian mode, so if I go down here to angle, I need to change that to degrees by pushing F1, because I'm using degrees as my measure of angle. Then I can go exit to go back. And so half 0.5 times and 6 times 5 times sine of 36.9. And I get, and to 1 decimal place is 9.0 centimeters squared as my area. Okay, and is that sensible? Looking at the numbers, that is a sensible value, isn't it? Always stop with trig. Always stop and think, is my answer a realistic one for the question? Okay, so the point of this was to develop a formula. All we've done so far is solve this particular problem. So what we want to do now is what's called generalize. So we want to turn these numbers into letters so that we have a rule or a formula that we could use if those numbers changed. So here's how we're going to do it. We're going to draw this triangle again, and this time we're going to change those numbers to letters. And here's how we're going to do it. We're going to label the corners, which is the angles, capital A, capital B, and capital C. And we're going to label the sides with lowercase a, b, and c. And here's how we're going to do it. We're going to make it so that little a, that's the side length A, is opposite angle big A, like this. And then little b is opposite the angle big B. And little c is opposite the angle big C. And this is how we're going to work throughout this topic with non-right angled triangles. We're going to use capital letters for the angles and lowercase letters for the length of each opposite side. Okay? Does that make sense? Alright, so now what we're going to do is we're going to write a formula for area, and we're going to mimic what we did with the numbers, except this time using the letters. So, area equals half times the base times the height. Now, which of these letters represents the base of this triangle? Well, it's the B, isn't it? So it's going to be half times B. Now we don't have a letter yet for the height because the height's not actually in here yet. It's actually, the perpendicular height is this part here. And I'm going to just call it height. I'm not going to call it H because we might confuse it with the hypotenuse. So I'm going to go half times B times the height. Now, the next thing we did back here was what? Well, we wanted to find a formula for the height based on the information we had. And it was 5 times sine 36.9. So, if we go back to this triangle, 5 is which side? Well, the 5, this is 5 here, is the side labelled C. So I'm going to go I'm going to go height equals, and it's, instead of 5, it's C, and instead of the angle 36.9, we're just calling that A. That's this angle here. So C times sine of A. So where height equals C times the sine of angle A. So I'm going to substitute that in now for the height. So pause the video and have a go at writing the formula that you get by substituting in C times sine of A for the height. See what you get. So hopefully you got half times B times C times the sine of A. And if we put all that together, we get area equals half BC sine A. And that is the formula that we call the area rule for a triangle. Okay, so let's apply it. Let's have a go at a question. Now, if you're copying notes on this, you should do what I've done and highlight this, because this is one of the key formulas that you need when you're assessed on this achievement standard. So if you're given a question like this, you wouldn't get the credit if you did it the two-step way. You have to show that you've used this formula as part of solving your problem. And this formula actually will be given to you when you do the test, but you got to use it. Okay, so let's have a go at an example. Okay, so here we go. Calculate the area of these triangles. So triangle A has an angle of 30 degrees, and we've got two sides of 10 centimeters and 7.6 centimeters. So step one is what we do is we label using the ABC method, we label the corners. Now, I reckon it's easiest if you just always label the given angle as capital A. You don't actually have to do that, but it's a nice simple way to remember it. So that's A, and then this is B and this is C. We'll go around clockwise. So then we label the sides opposite each angle with the lowercase version of that letter. So where's little a going to go? It's going to go here, and little b is going to go here, and little c is going to go here. Next thing we want to do, after we've labelled, is we want to copy down this formula here. That one. So, area equals half times b times c times sine of a. So step one was to label the angles on the sides. Step two is to write down the formula. And then step three is to substitute the numbers from the question into that formula. So half, and then b and c. B is 7.6 centimeters, so half times 7.6. C is 10 centimeters, so times 10. And then times the sine of A, and the A is the 30 degrees, so sine of 30 degrees. And then we grab our calculator, whack it in. So 0.5 for half times 7.6 times the sine of 30 degrees. And we get 1.9 centimeters squared as our answer. Whoops. So we go 0.5 times 7.6 times 10 times sine of 30, and 19 centimeters squared is our answer. Okay. Now, I want to think about what matters here and what doesn't matter. So, what do you notice about both these questions that we've done in terms of what we've needed to solve the problem? Well, in both of them, we've needed an angle and two sides. And what do you notice about which two sides we've needed? Well, if we zoom into the first one that we did, notice how the 36.9 degrees was in between the two sides that we used. Okay? And then in the second one we did, this one here, again, the angle, the 30 degrees, was in between the two sides that we knew. And that meant that the letters for the sides that we knew were different to the letter for the angle that we needed. Because which side did we not use in this formula, guys? We didn't use the A. We didn't need the side that was opposite the angle. Okay? So that's why the formula, notice how the letter for the angle is A, is different to the letter for the sides that we used. So what does that mean? Well, it means that we always are going to be using an angle sandwiched in between two sides. In other words, side, angle, side. S for side, A for angle, S for side. So it's always going to go side, angle, side. And you can think of that as sass. We want our triangle to have a bit of sass. Okay, what I'd like you to do is to practice some of these. So if you go to the exercise, and this is from the theta textbook, I would like you to practice enough of these to get the hang of this process. And you'll know when you've mastered it because you'll be able to do the questions at the end of that exercise and then get them right using the answers. See ya.